Picture this, you have heard the word Databricks in every job posting, but you have never actually opened it. And a little voice says it is too big, too expensive, too advanced. Let me kill that voice today. By the end of this lesson, you will have run PySpark, read a real file, and reshape data with your own hands. We start with the one picture that makes Databricks finally click. Then the very first comments you type, and the day one mistakes that scare beginners and quietly run up the bill. Zero to working. Let us begin. Here is the one idea everything rests on. A data lake is cheap, open storage for any file you throw at it, pictures, logs, CSV files, anything. A warehouse is the opposite, it gives you fast, reliable SQL on clean tables. For years, you needed both separately. Databricks does something clever. It puts a warehouse grade table layer right on top of your cheap lake storage. That combination is the lakehouse. Think of a real warehouse built on top of a giant cheap storage yard. One place, both jobs. That is the whole trick. Now, the second idea what makes it fast. Spark is the engine underneath Databricks. When you hand it a big job, it splits that job across many machines and runs the pieces at the same time. Here is the beautiful part. You write one line of code. Spark figures out how to spread it across the whole cluster for you. Picture a kitchen with many cooks, one recipe, the work shared, the dish done far faster. You write once. Spark spreads it everywhere. So why does Databricks even exist? Teams used to keep their raw files in a cheap lake and then copy those same files into a separate warehouse. For analytics, two systems, two bills, two copies of the truth. The lakehouse runs both analytics and big data jobs on one copy of the data. Less copying, less moving, far less operations work. And that is exactly why teams moved one platform for engineering, for analytics and for machine learning, one home for all of it. Let me show you the things you will actually touch. First, the workspace, which is your home inside Databricks. Then compute, also called the cluster, which is the engine. And then the notebook where you actually write your code. Your data lives in its own structure. Catalog, then schema, then table, all governed by something called Unity Catalog. Here is the simple way to hold it. Workspace is your office. Cluster is the engine you switch on. Notebook is your worksheet. Three jobs, three pieces. Keep them separate in your head and Databricks stops feeling confusing. Compute is your cluster. It does the actual work and it is the thing you pay for while it runs. Storage holds the real data files cheaply in the cloud and it is completely separate from compute. Governance is Unity Catalog. It decides who can see and use which catalog, schema and table. The cluster reads the storage and Unity Catalog decides if it is allowed to. That is the whole picture. Let us talk about creating a cluster. Just the concept, a cluster is simply a group of machines that runs your code. You switch it on when you want to work. My advice for day one, pick the smallest size available to start and then set it to auto terminate after a few idle minutes. This matters more than anything. Switched off means no compute bill at all. Auto terminate is your safety net from the very first minute. Turn it on before you do anything else. Now let us tour the notebook itself. A notebook is just a stack of cells. You write code in a cell, hit run, and the result appears right below it. Look at the very top of the notebook. There is a selector to attach it to a running cluster. That attachment is what gives your notebook an engine to run on. And here is the single biggest beginner confusion. The notebook is not attached or the cluster is not running. Remember this one, we come right back to it later. Time for your first command. Type spark.version and hit run. That is it. It prints the Spark version running on your cluster. And you just ran your first real command on a distributed engine. The output appears right under the cell. And that simple fact tells you something important. If it runs and prints a version, your cluster is alive and attached. Small command, huge milestone, you are officially in. Before we read data, one quick word. What is a data frame? A data frame is simply a table in code, rows and named columns. Like a spreadsheet you can program, behind the scenes Spark splits that table across the whole cluster. But you get to treat it as one single thing. That is the magic of it. And here is a pattern worth remembering. Every read, every filter, every group by you do produces another data frame, one table in your code, many machines underneath. Now let us read a real file. You call spark.read.csv and point it at a file path. Header equals true tells Spark to use the first row as your column names. And info schema lets it guess the data types for you. Notice the path starts with Databricks datasets. That is a built-in sample folder that ships with every workspace. which means this line runs without you uploading a single thing. Perfect for learning real data, zero setup. You have read the file, so now let us look at it. Call display of your data frame that renders a clean scrollable table right inside the notebook. Prefer plain text df.show of 5 prints the first 5 rows, and df.print schema shows you the column names and their types. Here is the subtle bit calling. Display or show is what actually triggers Spark to read the file. Up until now, nothing had really happened. This is the first thing that truly runs. Now for your first real transform, you take your data frame and call filter, keeping only the rows where year equals 2007. Then you chain group by month and count. Filter keeps the matching rows, group by month, and count gives you the number of rows in each month. Then display of result shows it. And look what you just did, your first real mini analysis, computed across the entire cluster. That is data engineering right there. Here is something that surprises people. You are not locked into PySpark. Call, create or replace temp view and give your data frame a name like flights. Now you can query that exact same data with plain SQL. Write %SQL, then select month count from flights, group by month, and you get the identical answer just in SQL style. Same lakehouse data. Two languages, pick whichever one reads clearer for the task in front of you. No wrong choice here. Right now, your data is just a variable in a notebook. Let us make it permanent. Call df.write.save as table and give it a name that persists it as a governed delta table. Notice the name has three parts. Main demo flights, that is catalog, then schema, then table. Using that fully qualified name avoids the classic which table did I mean mistake. And now it is a real query anywhere table, not just a variable that vanishes when the notebook closes. Now, I have to warn you about the thing that trips up almost every beginner. It is called lazy evaluation. Your reads, your filters, your group bys are all lazy. They only build a plan. They do not actually run yet. The work only fires when you call an action. Display, show, count or write. That is the trigger. So when a cell seems to do nothing instantly, it did not fail. It was simply waiting for an action to wake it up. Once you know this, the surprise disappears. Let me hand you the three errors you will absolutely hit and the fix for each one. First, cannot run cluster not attached or terminated. The fix is simple. Attach the notebook and start the cluster. Second, table or path not found. That is a wrong catalog, wrong schema or a typo in the path. Check the exact name. Third, my transform did nothing. That is lazy evaluation. Add an action like display or count to make it run. Three errors, three fixes. Screenshot this one. Let us talk about billing, and please do not panic. You are built for cluster compute only while it is actually running. Plus cheap cloud storage for the files, which is almost nothing. A terminated cluster costs you 0 for compute, nothing. And that is the whole point of auto terminate. It is your safety net, the fear of waking up to a runaway bill. It simply goes away once auto terminate is on. And you start small, control the cluster, control the cost. So what should you not do on day 1? Do not leave a big cluster running. Start small and let it auto terminate. Do not call display on a giant table just to look around. Use df.show of 20 or add a limit instead. And please do not turn off auto terminate. I mean, that one single setting prevents the vast majority of beginner builds. Leave it on every time. Let us lock in the three pieces one more time. Compute is your cluster. It does the work. It is built while running and you control it with size and auto terminate. Storage is your data files in cheap cloud storage. It is constant and completely separate from compute. Governance is Unity catalog. It decides who can use which catalog, schema and table. Those are your access rules. Keep these three straight and Databricks makes sense. Take a step back and look at what you just learned, the mental model. Lakehouse equals lake plus warehouse and Spark spreads the work across a cluster. The loop, attach a cluster, read a file, transform it and display the result. All while watching the bill with auto terminate. That is not theory anymore. That is a real working foundation in PySpark. Built by you. In one lesson, be proud of that. Let me leave you with a cheat sheet to keep the objects, workspace to cluster to notebook and your data is catalog to schema to table all under Unity catalog. The first commands spark.version, spark.read.csv, display, filter and group by and count and write.save as table And the golden rule, small cluster plus auto terminate fully qualified names. And remember that an action is what triggers the work. Screenshot this. It is your starter map. Look at how far you came. You can attach a cluster, read a file, transform it with PySpark, and save a real table. That is a genuine start, not a toy. When you are ready to build it for real, the full Databricks course is linked below. Clusters, Delta, pipelines, the whole craft. And if this made Databricks click for you, subscribe for more data engineering. One question before you go. What will you load first? Drop it in the comments. I read everyone.